Welcome to Plutus. And today we are covering nomenclature of the coordination compounds. This is lecture number 4. We have already covered EAN rule, coordination compound, basic terms, how do they form, the types of ligand. If you haven't seen those lecture, I highly recommend please go visit them. You will find the playlist link down in the comment in the description. Now, as we are saying, we are talking about the nomenclature of the coordination compound. So, how do you define the formation of a compound? It is because the ligands are the first one who are interacting with the metal center, or it is the metal center that is receiving the electrons, or it is allowing the ligands to attack itself. Now, the basic principle remains nearly the same as in the case of your organic chemistry. We always write the substituent, or in this case the ligands first, then we'll move from higher priority to lower priority based on alphabetical order. Since the point of arrangement is exactly same in all the cases, so there is no need to mention any position. There is no rule as such as lowest locant rule. You can directly start from naming the ligands in the alphabetical order, A being the first, then B, then C, and similarly down below. At the very end, you will get the metal center right at the center, because it is the main point of attachment. So you can consider it to be like your main parent carbon. Then you'll write the oxidation number in your Roman numerals, and if your coordination sphere carries negative charge, we'll add a suffix that is ate at the end of the name. So let's say cobaltate, ferrate, etc. And if the coordination sphere is positively charged, then there is no need to add anything. Then, if you have counterions, counterion depending on their position when they are used first, for example, cationic counterions are represented first, hence their name is written normally. Then your anionic counterions are written always at the end, leaving the space between the name of the compound. While specifically for the case of coordination complexes, the name of the entire complexes is written in a single go without lifting the pen, without leaving any gaps, except for the case of your counter ions. So let's talk about them in detail. First, your coordination sphere can be both positive and negatively charged, and the cation is named first, followed by the anion. The ligands are named in alphabetical order that we have already discussed in the form of central ion. This is the name of the ligand that you will find. Your anionic ligands such as N3 minus, Cl minus, they will always be written by adding a O behind the name. For example, azido, chloro, bromido, fluorido, cyanido, etc. Then O minus is peroxo, Br minus bromo, OH minus OH2H minus per hydroxido, Cn minus cyano or cyanido, S2 minus sulfido, O2 minus oxo, NH2 minus amido, OH minus hydroxido, CO2 minus carbonato, NO3 minus nitrato. So these are the name of the ligands. You'll find this entire PDF linked in the description in the drive. Okay. Once you've done this, the nature of neutral and cationic ligand, except for the case of water and ammonia, these are neutral ligands, so their names are written in a different manner. For example, H2O is written as aqua, NH3 is written in amine with a double M, carbon monoxide as carbonyl, NO as nitrosyl, CS as thiocarbonyl. Positive ligands are not part of our syllabus, so you can entirely avoid them. Now, if your same type of ligand appear more than once, we write di if it appears twice, we write tri if it appears thrice, tetra, pent, hex, hexa, based on how many times the same ligand is arriving. But if you are having a ligand which already contains these words like di, tri, for example, ethylene diamine. Ethylene diamine already contains the word di in itself. So if you start writing the name en whole twice, how would you write it? So for such kinds of ligand, we use new terminology, that is, you add prefix. Bis if the ligand appears twice, tris if it appears thrice, tetris if it appears 4 times, and pentes if it appears 5 times. And there are no further variations to it. Then oxidation number can be calculated by normal means, as in the case of your normal redox complexes. For example, The complex is given as Cr, Cl2, H2O, whole 4, Cl. Finding coordination. Since C counter ion is one single Cl, so that means the total positive charge on the coordination sphere would be 1 plus. Finding oxidation state, H2O is whole negative, Cl is minus 2. Minus 2 goes to the other side, positive will get added. So Cr is in plus 3 oxidation state. Writing the name of the compound. Aqua A Cl chloro. So A will be written first. The name would be tetra aqua, first letter capital, aqua without leaving space, then dichlorido, then oxidation state is positive charge, so we can directly write chlorido chromate, sorry, chlorido chromium, oxidation state in Roman numerals plus 3. Since the counter ion lies on the right hand side, now we will leave some space and we will write chloride. Now remember, even if it was Cl2, you will never write dichloride. Why? Because while this number will be utilized to add the positive or negative charge on the coordination sphere. So it is already included how many number of counter ions are already there, because the finding of the oxidation state of the metal was the prime basis that the how many counter ions are there on the outside. So you will never write dichloride, trichloride, etc. in the form of counter ion. Another example, let's say something which is negatively charged. Now, if you have a ligand which contains bridging ligand, or a single ligand is joining two metal center, then for that particular ligand, you will add the suffix mu or whatever the ligand say it is. Let's say hydroxido, NH minus, amido, mu hydroxido, just to represent the bridging ligands. Another example, let's say we have we have this Hg, cobalt, SCN, whole 4. Now, mercury is the counter ion positively charged and SCN4 minus. Now, mercury in normal scenario exhibit plus 2 oxidation state. Can exhibit plus 2 and Hg can also exhibit plus 3 oxidation state. Here, SCN is a negatively charged ligand, carries minus 1 charge. There are total 4 on this side. 4, and since this is positively charged, then definitely there will be a negative charge, minus 1 here, because this will first show plus 1 and this is minus 1. Solving minus 4 on the other side, negative 3, it will give you plus 3 oxidation state. Naming counter ion, will write mercury, which is the counter ion, leaving space. Then we have tetrathiocyanide, then we have cobalt, but since it is negatively charged, we will add the suffix 8, cobaltate, oxidation number in Roman numerals. That's it. And since there is no further counter ion, so it will remain like this. So that's how you write the nomenclature of coordination compound. I hope this would have cleared all your doubts regarding the nomenclature of coordination compound and how do you write them. For any doubts, any other clarification, you can add it to the comment section, and this PDF is also attached in the description of the drive. You can find the drive link in the description. So that's all for today. Thank you for joining us.